bits and pieces within each layer. Some of the fundamental, we'll do some of the main protocols and main algorithms within each layer, not all the main algorithms. Essentially, in a networks class, you would do all the main algorithms. Here we will do samples and an overview of the layer of each layer's workings and how what it does and how it does it. Is everyone with me? And I'm just recapping where we are so far. Then previously, I think we have seen the physical layer in all the detail we'll need to. So once again, in chapter 2, right, there were 2 slides on each layer. So subsequently, we will do, guys, I need a minute. Okay. Okay, so once again, previous chapter we saw an overview of the layer of the protocol stack, and then a little bit of what each layer does, right? At an introduction level. So what the main functionalities of each layer. Now, for the physical layer, what the introduction we have learned, that is sufficient. That is all we need to know for this class, because details of the physical layer goes into the topic of digital signal processing, right? That goes into electrical engineering and computer architecture. Essentially the DSP class and computer architecture. So today, the other thing to note is also, I mentioned before, right? There are about 4 or 5 standard textbooks around the world. And so the way each book does is, once again, it will have an introduction chapter where it will present the 5 layers, and then each chapter will go into the details of each layer. Now, these books are organized in 2 ways. Some of them take a top-down approach, which is they explain the application layer first. And that is the user's perspective, right? So as a user, we deal at the application layer. So the books that take the top-down approach start with telling the story from the user's perspective. And then from the technical perspective, it's at the bit level and it's bottom-up. So some other books take the bottom-up approach, which is they explain the physical layer first and then bottom up. And as long as it's coherent, right, either way is fine. So this book takes a bottom up approach. So first would be the physical layer, next is the link layer. So physical layer, as I said, the introduction was sufficient. More details would become the topic of the DSP class. So today we'll go into chapter 9, which deals with the link layer. Does anyone want to say anything? Yeah, no, I was just giving introduction. So now, if can you see the slide? I just started. So that was just trying to recap where we are, right? Now, you don't tell me anything about previous classes, so I want to be sure you're with me, right? The first 4 lectures. Okay, so this is then we go into chapter 9, which deals with the link layer. So today and next class we'll finish. This week we'll finish chapter 9. Okay. So communication at the link layer is node to node. A data unit from one point in the internet, or this also data unit. So we also have to recall that a packet is given a special name at each layer. Does everyone remember? So what is the packet called in layer 2? Again, you look into the previous slides. Yes. Others?
frames.
Exactly, right? It's called a frame. So the link layer's job is, the link layer is also point to point. So at the link layer, there is very little difference between a logical connection and a physical connection. And we went through this before. A link layer only deals with the peer-to-peer the next node in the path. A path is the full path. A link layer deals with the next node. So, and at the link layer, there is very little difference between a logical and a physical connection because these two nodes are physically connected. It could be a wireless link, but it's one link. There is no intermediate node. Right? So this is once again where network engineers and electrical engineers differ in their viewpoints. Let me change to a pointer to laser. Right, to the electrical engineer, there is the physical medium, which is the physical connection. So this is still link layer is essentially the not essentially, it is the network adapters in your machines. Okay, so a data unit from one point in the line needs to obviously pass through many networks to reach another point. So this is saying to go from the source to the destination, it may need to go through various intermediate nodes through various links. And these LANs and WANs are connected by switches and routers. So the next slide is a simple representation of links and nodes when the path, as an example, is 6 nodes. Right? That's the full path. We assume this is the source, this is the destination. Say you are trying to download a web page. So this is your client machine, this is the server where the web page resides, and your route happens to take you through these intermediate routers, intermediate nodes. So this would be your home. This would be your home router, right? That is connected to your ISP's router, right? And then the ISPs are interconnected through intermediate ISPs. I want you to take a look at this picture, right? And imagine, understand that this is a very reasonable snapshot of the way we use the internet every day, right? Assuming you're, let's say, you're downloading a web page or watching a movie on Netflix. Okay. Now, the link layer, what does it do? So it's located between the physical network layers and it provides services to the network layer and it receives services or uses the physical layer. These 2 bullet points, the concepts will be applicable to every layer. So every layer provides services to the layer above and it does so by using the layer below, everyone. Right? So every layer is physically connected to the layer above and the layer below, and it is not even aware of any of the other layers. So the link layer does not know what the application layer is. Right? The link layer knows the network layer will give it some orders. It will accomplish that by using the physical layer. Receiving in, the physical layer will give some packet to the network layer, which will pass it to the link layer, which will pass it to the network layer at the receiving end. And the link layers at each end feel logically connected. Everyone, right? This is just the general architecture. So the scope, the specific point is the third bullet point. So the scope of the link layer is node to node, as I said before. So when a packet is traveling in the internet, the data link layer is responsible for delivering a datagram, which is the layer 3 packet, to the next node in the network. So the link 3, once again, the link layer's job is to deliver it to the next node. I need another break, sorry. Okay. Oops, sorry. The link layer and the sending side needs to encapsulate the datagram received from layer 3 into a layer 2 frame. So the layer 3 packet is a datagram, right? So the link layer is given a packet by layer 3, which is the datagram, encapsulates, which means add its own headers and parity bits, and the layer of the receiving node needs to again decapsulate the layer 3 datagram from the layer 2 frame. Does this make sense? Everyone? Exactly. Exactly. So the reason for conducting encapsulation and decapsulation, I think, node is then we also have a point to note. Each link may be using a different protocol with a different frame format. And at the layer 2, each link is different. We use that again in everyday life, right? We use a wireless link with our home router, which has a connected usually with an optical fiber to the ISP's gateway. So the protocol may be different, frame format in each link may be different. So even if one link and the next using the same protocol, then encapsulation, decapsulation are needed because link layer address pairs are also different. So at the link layer, for the first traversal from A to B, this is the source MAC address, this is the destination MAC address. For next one, this becomes the source MAC address, this becomes the destination MAC address. Another diagram. And so here, layer 3 sends a datagram to layer 2. Layer 2 will add its own header, and it's not shown. It will add its parity bit at the end as well. It will use the physical layer to transport this. So this physical layer, as an example, is of type 1 to this router's this interface. The router will receive, it will remove the layer 2 datagram, a layer 2 header, give it to the layer 3. Layer 3 will somehow has decided that the next link is this one, type 2. So it will give it, send it to the outside port, right? The layer 2 in the outside port, this direction. And each interface in the router has a separate LAN card, has a separate MAC address. So here, this router as an example is given as having 3 interfaces. So this if it's going on this outgoing interface, this link layer will add the header appropriate to this particular port. It will again travel to the server, go to link, the physical layer will give it to the link layer will again remove the layer 2 header and give it to the layer 3 of the server. We'll see another example. What is the মাঝখানে কি করছে আবার বলো? এই রাউটারটা কি করছে? ওকে, না বুঝলে বলো, অসুবিধা নাই। Everybody else, please, না বুঝলে বলো। মানে আচ্ছা, ওই চ্যাপ্টার 9 it's short, so plenty of time in the lectures. Okay. Then next হচ্ছে different services provided by the link layer. I will define 4 concepts. ঠিক আছে? So main architecture টা বুঝলাম এখন। These are first 2 are very straightforward. Next, the last 2 are new concepts. So first are framing. Framing just means proper encapsulation and decapsulation in the proper format for the particular protocol of that link, and putting the addresses properly, just putting it in the proper format for that protocol. So the link layer, each node needs to encapsulate the layer 3 datagram into layer 2 frame before sending it to the next node. Receiving layer needs to decapsulate the layer 3 datagram from the layer 2 frame. And different link layer protocols have different frame formats. So just putting it in the appropriate format. Right? নতুন কিছু না। Error control. এটাও হচ্ছে exactly a recap of what we learned in DLD regarding parity bits. But the sending node or frame in the link layer needs to be changed to bits, right, at the physical level, then convert to electromagnetic signals and transmitted through the transmission medium. Receiving node, the electromagnetic signals are received, converted back to bits and recombined into a frame. Okay, sir? Now, since electromagnetic signals are susceptible to error, a frame is susceptible to error. And in the past, I mentioned the two main causes of error are attenuation and noise. Right? Attenuation means just signal absorption in the medium. The amplitude goes down with distance. And noise is unwanted signal. So because of attenuation, a 1 may be misread as a 0. The 5 volt may keep reducing and become close to 0 volt. Because of noise, a 0 volt may be received as 3 volt and be misinterpreted as 5 volt, as a 1. So bits may be flipped in transit, right? And then we recall from parity bits, some errors can be detected, but not all errors. Remember, if 2 bits are flipped, the parity checker cannot detect that. You remember? 1 bit is flipped, it can detect. If even number of bits are flipped, it cannot detect. Then there are more sophisticated parity checkers where up to 2 bits can be detected, and if 1 bit is in error, exactly which bit is in error, that can also be detected, called a two-dimensional parity check. Is everyone with me?
Yes, sir.
Yes, sir.
I mean, once again, I'm not going to ask you to do a parity check, but the idea is what I need to know, that it can be done. So the last 2 points are very important. So first thing to realize is all errors cannot be detected. If an error is not detected, the link layer at the receiving end will pass the frame to the upper layers, will pass a wrong frame to the upper layers. Now, maybe the upper layers will detect it, maybe not. That's a separate issue. Once again, if it's a banking thing, you want to be, as you cannot be 100% sure by using packet network, but you want to be 99% sure. So upper layers use other protocols to detect. So at the link layer, error may be detected, may not be detected. Okay. If it is detected, then what are the options? First option is you can still ignore the error and send it upstairs. That is rare. I don't know of a case where that is done, where error is detected but still ignored would be the term. Okay. So the next is, if it is not detected, you don't have a problem at the link layer. You're not aware of the problem. If it is detected, you can either ignore, which is never done, or you can do something about it. Okay. If it is detected, then next point is, can you detect which bit is in error? First is, it is detected, you do not know which bit is in error. Okay. Then you can either discard the packet, right? Delete. So I'm saying if you do not ignore means you detect the packet, but you still send it upstairs. So I'm saying that is a rare scenario, right? You would never want, I cannot think of a scenario where you would want to do that. Okay. So you detect, you do not ignore. Then the next option is you can either discard, right? And then you can ask for it to be retransmitted. Discard and ignore. You can also, if it's real-time transmission, you will just delete that frame. Then one frame, you cannot wait for it to be resent, right? So you will delete. Next is, do you ask for a retransmission or do you just present the next frame? Okay. If you can, these are all the options. If you can, next is, this is if it can be detected. Now, if you can also detect which particular bit is in error, you can also correct it at the receiver. Right? If you can detect, first thing is you detect one bit in the frame is wrong. You don't know which bit. So then your decisions are, you delete the frame. Then do you ask for it to be retransmitted or not? Depends on the protocol. If you can detect which exact bit is in error, then you can just correct it at the receiver. If you know which bit has been error, then you know one is, if it's a 1, you know it was actually a 0. If it's a 0, you know it was actually a 1. Are all the options clear? I think if you break it down as a tree diagram, we've gone through all possibilities. First is error can be detected, cannot be detected. If it cannot be detected, you pass it upstairs. There's nothing you can do. If it has been detected, do you ignore? You don't, right? If you don't ignore, then options are discard or correct. There, if you know how to correct, or ask for it to be retransmitted. Okay. Is this slide clear? Take another moment. There are error detection, right? These are also fields of research, current research. Parity bit is the simplest. Has everyone heard of Caesar cipher?
Yes,
Right?
sir.
Has anyone not heard of it? This was the first encryption technology. When you study encryption, it's the first encryption technology or algorithm. It was invented by Julius Caesar. Is anyone not aware of it? So everyone's aware of it? Okay, that's very good.
Yes, sir.
Please, if anyone's not aware, tell me. Can someone else say what it is?
Sir, shift cipher এটা
Yeah, how it works?
পরের 3 বিট করে মানে
স্যার অ্যালফাবেটের কি তিনটা স্টেপ
নাম্বার নেওয়া হয়, let's say 3. Let's say একটা কি ডিসাইড করা হয়, let's say key is 3, which means প্রত্যেকটা লেটারকে তিনটা লেটার ওই যে পরের তিনটা লেটার দিয়ে রিপ্লেস করা হবে। মানে A will be replaced by a D, B will be replaced by an E, C will be replaced by an F, এভাবে। So receiver আবার এটা মাইনাস করে ফেলবে। So this was actually the first use of encryption Julius Caesar-এর সময়। My reason for saying this is nowadays obviously we have more sophisticated encryption method algorithms, right? And encryption and decryption is the topic of PhD research. Similarly, error detection and correction is also a topic of PhD of similar research at the moment. Parity bit is the Caesar cipher equivalent of error detection, like the simplest scheme. Okay. এখন এই রিসার্চ টপিকস আর এই যে এনক্রিপশন, এরর ডিটেকশন এন্ড ভুলে গেছি হাউ টু জিপ ফাইলস, মানে how to represent data, same information in using less number of bits. Compression, exactly. Compression and decompression, exactly. টার্মটাই হঠাৎ করে মাথায় আসছিল না। Compression, মানে these are current, they will always remain topics of research. Okay. More sophisticated compression and decompression algorithms. Okay. এই দুটো হলো আচ্ছা। Sorry, we've learned framing, error control. Okay. এই দুইটা টার্ম হচ্ছে they're similar but with a subtle difference. So I'll first explain with this diagram in mind, then we'll go to the slide. So once again, imagine you're downloading or you're watching in real time a high definition movie on Netflix, okay, or on YouTube. Let's say YouTube. Someone mentioned in one of my classes that YouTube use korle dekhba je it gradually increases the speed, everyone, right? Suppose you're watching a high definition link on YouTube, Netflix na. So has everyone noticed it? YouTube gradually increases the speed. এখানে reason হচ্ছে YouTube is trying to see that there could be various bottlenecks and each intermediate node you might have in your full path. Suppose Bangladesh's backbone submarine cable is down. We're using, as I mentioned, a backup satellite terminal as a temporary measure. Let's say in between our backbone, the submarine cable is down. We're using VSAT, which is very small aperture terminal, which is our backup link, which we used to use before the submarine cable connectivity. So this link is slow. This link cannot support, let's say there is an international event going on, many people are watching on YouTube. So this link cannot support that many high-speed communication at the same time. An intermediate link, right? This is one scenario. So what will happen if the server is sending packets at a high rate for many people watching? Let's say from here there are branches, many people are watching some high definition link. So sorry. So if this is the link that is broken, let's say this is the server, it's coming to this particular node. This node cannot send to this node at the speed at which it is receiving. So buffer of this node will keep on getting full and full and full. Ultimately, when the buffer is function of memory, it is finite. When the buffer is full, it will drop the next packets that come in, right? It will not have space. So packets will be lost in the link. Another scenario, suppose all the backbone links are fine. Your own connection is a slow dial-up connection, and your scenario B, and you're trying to watch a high definition link, high definition video. So your dial-up connection will not be able to process at that speed. Scenario C, all the links are very high speed, but your machine is very old with very little RAM and very low processing power. Very low RAM means it has very small buffer. So then if the jitter is high, jitter is not delay, right? The variability of in the delay. If the jitter is high, which means your node must, in its buffer, store a large number of packets before it starts playing, to make sure it doesn't receive any packets out of sequence, right? It has to store if the jitter is high, which means it is receiving packets out of sequence. So it might receive packet 10 before packet 2. So it will make sure that it has received has a storage of 100 packets before it starts playing. Because if it starts playing late, you don't mind. If it buffers in between, that is when you are annoyed, right? But if your high jitter, but your RAM is small, you cannot store 100 frames. So then you will buffer, right? Your playback will buffer. Okay. Suppose you have enough RAM but low processor, it cannot process so many packets at the same time. The different scenarios. Is everyone aware of all the possible bottlenecks? Now let's go into these two slides. So flow control deals with not the sender. Flow control deals with the sender not sending at a rate higher than what the receiver can process for the two ends. So the receiver will send a feedback saying what is the largest number of packets per second, or if its RAM is getting filled up, it cannot buffer anymore and it's not being able to play back, or its processor cannot process so many frames per second. Then and ask the sender to slow down. This is called flow control. Congestion control is when any of the intermediate nodes are getting frames sent at a rate higher than it can process. Is the distinction clear? Let's see the slides. So flow control means if the rate of sent frames is higher than the rate of received frames at the receiver, at the receiving end, right? Where the receiving end need to be buffered for waiting to be processed. Buffer side and the receiving side is finite. So we can then either let the receiving link there drop frames when the buffer is full, or let the receiving link layer send a feedback to the sending link layer to ask it to slow down. Right? Okay. Right. So this is flow control means for the sender not to send at a rate higher than the receiver can process, and that is what YouTube initially does. Is it tries to see at what rate you can process, and then it sends the receiver messages, the server messages that okay, I can take more, so send more at a higher speed. And different link layer protocols use the different ways of doing this. Okay. I'll get into the last bullet one later. Congestion control refers to the intermediate routers in the network receiving frames at a rate higher than it can process. That is the difference. common network question is to ask the difference between the two. So the intermediate routers in a network receiving frames at a rate higher than it can process. And again, same thing, buffer size of the intermediate routers are also finite. And I mentioned this term, core means intermediate, the intermediate points, and edge means the ends. So again, yeah, same thing, we can then either let the receiving link layer know when packets are full. Right? ওই যে আবার ডিফারেন্স হচ্ছে হ্যাঁ মানে দুটার অবজেক্টিভই হচ্ছে টু রিডিউস কনজেশন, বাট ফ্লো কন্ট্রোল ইজ এন্ড টু এন্ড। কনজেশন কন্ট্রোল ডিলস উইথ ইন্টারমিডিয়েট রাউট নেটওয়ার্ক। হ্যাঁ হ্যাঁ মানে মানে তোমার এখানে এই যে এভরিডে সিনারিও চিন্তা করলে ওটাই বলছে যে ফ্লো কন্ট্রোল ডিলস উইথ ইফ essentially servers are able to send at high rates. If your last link, right, your own connection to your ISP, right, and your own machine processor can handle this high rate. And congestion control means the backbone internet is congested. So তার মানে কি পুরো if the backbone internet is congested হয়ে গেছে, so congestion control এর রেজাল্ট হবে মানে everybody sending is supposed to slow down. Right? So যে এখন মানে during the with the pandemic, right, with lot of activities going on online, right, the entire country's in network is is inundated. Grameen's full data network has a high load, right? So তার মানে যেটা করতে হবে, Grameen needs to slow down sending. Grameen ধরো গ্রামীণের ব্যাকবোন কানেকশন যেটা টু লেটস সে BTCL, মানে Grameen needs to slow down at that route. বুঝতে পারছো? মানে ফ্লো কন্ট্রোল ইজ ওয়ান পার্টিকুলার ইউজার, আর কনজেশন কন্ট্রোল ইজ এন্টায়ার ব্যাকবোন ইন্টারনেট. So congestion control will affect everyone, right? আচ্ছা এখানে আরেকটা এক্সাম্পল দেই। হ্যাভ ইউ গাইজ সিন এনি ওই যে ওয়েব ব্রাউজার গুলো অনেকগুলা ডাউনলোড অ্যাক্সেলারেটর অ্যাড-অনস থাকে? Is everyone aware of it? Or is anyone aware of it? Have you encountered this? Right, everyone? ওই ডাউনলোড অ্যাক্সেলারেটর যেটা করে হচ্ছে in network, what it does is not illegal but unethical. What it does is when a network is congested, not flow control, when it's congested, ki backbone network is all the একটা তো হলে usually হয় না, let's say multiple intermediate routers are congested, right? So result হচ্ছে everyone is supposed to slow down. Download accelerator যেটা করে, it will make sure your browser does not slow down. মানে পরে দেখবো যে এটা এই একটা লাইন লিখেছে আমি এখনো বলিনি যে এই দুটো যদিও এই লেয়ারে ডিফাইন করা, even though these are defined in this layer, flow control and congestion control is typically done at the transport layer. ঠিক আছে, মানে বিকজ ওই রিসিভিং এই রিঅ্যাকশন গুলা এন্ডে করতে হয়। if a intermediate router is congested, the router cannot stop the congestion. The server must send slower, right? If your client is congested, right, running out of buffer, again the other end must send slower. বুঝতে পারছো? So that's why on transport layer, other end it's a transport and application layer. So that's why these are typically done at the transport layer, because intermediate devices cannot do much to stop this. Okay. Download accelerator. So typically, if there is a congestion, transport layers of all the devices interact to reduce speed, all of them. And what a download accelerator will do is, it will tell your device, your browser, to override that slowing down instruction. So what will happen is you will not slow down, but the others will slow down. So you will end up taking bandwidth from the other people. So it's a fairness issue, in the sense the shared connection will then not be shared evenly. So on no device to the other people in the network will keep getting messages, so the network is more and more congested, so they will keep more and more slowing down, and whatever network bandwidth is freed up, your browser will confiscate that. But the whole anyway. Yeah, anyway, so a slider objective of the twofold. First, to learn the definitions of what is flow control and congestion control, right, and how it's resolved. And next, we'll see details of how it's resolved is at the transport layer. And it makes logical sense why it is at the transport layer, right? Because end-to-end phenomena. But because these needs to be addressed end-to-end.
So what would happen if everyone in the network is using download accelerator?
Then the download accelerators will not work. Or good point. Or if you assume the download accelerators work, right? They force to keep sending. Then the intermediate routers will keep on getting congested and keep on dropping packets. So quality will suffer for everyone. So the download accelerators work on the premise that not everyone is using it. So everyone will slow down, and you will take over their share of bandwidth. Right, and everyone is using it, then download accelerator, then it will not work for anyone. Very, very good question. Okay, this we have seen, right? Links will be dedicated or shared. There's nothing more. Okay, final topic of the day is link layer addressing. So one of the slides initially we mentioned, I mentioned, right, that we name packets at each layer, right? The packet is called a separate term in each layer, and each layer also has separate addressing. So again, let's give you let's have a minute's break. It's time. So right? Transport layer, it's port numbers. Network layer, it's IP addresses. Link layer, it's the MAC addresses. So IP addresses are unique to each connection. We'll see the difference later, right? And MAC addresses are hard coded to each of your network adapters, and MAC addresses are unique. So everyone knows what a MAC address is, right? You knew it before and gone through it, right? It's the network adapter hardware physical address. And we know that, so if you route using IP addresses, so we know that, this diagram. Suppose there are in between from from the beginning to the end, suppose there are, or not suppose, there are multiple routes as alternative routes as well, right? So in a packet switch network, each packet may not necessarily take this same route. Packets may take multiple routes. MAC address deals with each individual link, right? So this example will make it clear, actually. Yeah, that will make it clear. Okay, so each datagram in the internet, at the let's say from the same host to the same destination. Destination host is confusing. Same destination may take a different path. They take a different path. The link layer address is forwarded point to point over a single link. So link layer address is also called a link address, physical address. This is the name MAC address. So imagine this scenario. So Alice wants to send a message to Bob. So this is Alice's home router, and I've mentioned before that is actually a switch. It is not a router, which means it has no layer 3. It has only a layer 2, up to a layer 2. The switch is connected to the ISP's router. The ISP has 3 interfaces on its router. That is connected to, this is Bob's ISP. These 2 ISPs are connected through this intermediate switch. Okay. Let's say Bob's. So then this is particular, this interface connects Bob's machine to its ISP, again through this. This is his home router or a switch. Is the scenario clear? মানে হ্যাঁ, এখানে typically যেটা হবে, it will be different routers. It is this is a picture from the book, right? This is likely to be another router, not a switch. Not a switch, because this makes no sense. I cannot think of a realistic scenario where this will happen, right? But for the example I'm trying to explain, it doesn't matter. Like I said, that these two are switches, this matters. This is relevant to the example. Okay. So how will the packet flow? So here Alice, let's say this is Bob is a server. So Alice types in a URL, presses enter. So the application layer will encapsulate into a transport layer packet. Transport layer will decide whether to use TCP or UDP. Suppose he uses TCP, go to the network layer. Network layer will encapsulate in a network layer datagram. Now there the network layer will put in the correct addresses. So as a source IP address, network layer will put in N1. Assume that this is the network layer address of Alice, IP address. N8 is Bob's IP address. The application layer will figure out that the URL you mentioned refers to Bob, and this is Bob's IP address. When you put in a web page, when you put in a URL, you do not put in the IP address. During inside IOB, oftentimes to use the attendance IRIS, everyone remembers the IP address memorized, right? People have put it in the URL. Typical case, we will put the URL. There is another application, another process that occurs which maps the URL to the IP address. Your web browser will look up an international database to do that mapping. Okay, so that's in the background. So somehow the application layer has found the IP address. We knows that the URL IP address is N8. Okay. So the network layer packet will have N1 as the source IP, N8 as the destination IP. Network layer will give it to the link layer. Everyone please follow. Network layer will give it to the link layer. Link layer will then add, link layer sees that the next link is this switch. Sorry, this router. So here it's assumed that this is not even a switch. This is just a repeater. We'll just has only layer 1. So we'll send it to this particular, this is the next interface. Link layer, this one's MAC address is L1. This interface has a MAC address L2. So this packet will then have the data. This is from the application layer. We'll give the message to the transport layer. Transport layer will add the TCP headers, right? That is encompassed in the brown box. The data here means application layer and network layer packets. Application layer, sorry, and transport layer packets. One of you should have pointed it out. Network layer then adds N1 and N8. N1 as the source IP, N8 as the destination IP. Then this intermediate, this box gets sent to the link layer. Link layer will add L1 as the source MAC, L2 as the destination MAC. This packet will then traverse this particular link. So the link layer is one hop always. Link layer is always one hop. This particular link to this particular interface in router R1. Router R1 will then decapsulate. So it sees this packet. It sees, okay, this is meant for him. L2 is the destination MAC address, which is this particular interface. So I'm correct in receiving it. This MAC address knows, this link layer knows it is correct in receiving it. It is meant for him because the destination MAC address matches his MAC address. He sees this packet has come to me from L1 node, from Alice. So he will remove this. He knows he can provide service to Alice. So he will see that, okay, the destination MAC address matches me. So this packet is meant for me. So he will remove this, do the parity check, right? If the packet is in error, he will delete. Assuming parity bits match, he will then send the intermediate, he will remove L1 and L2, this headers, send the rest of the packet to the network layer. Everyone. Network layer will then read its part. It will read that, okay, it came from N1, IP address N1, which is Alice. If it's an ISP, you will see, okay, Alice, he has paid his bills, so I am okay to provide service to Alice, right? Okay, it says destination is N8. It will look at its routing table and see that how it's done. Again, is a separate issue. And he knows that, okay, N8 is in this direction for me, not in this direction, not in the top direction, in the right direction, right? This router happens to have 3 interfaces. N8 could have been in any of its 3 interfaces. It will look at its routing table and it will see that N8 packet I must send on this particular link as the next hop. So it will send the packet down to this right side network adapter. A router at each interface will have a separate network adapter. It will again send it down to the network adapter on the right side, right? As in this format. Again, source IP is N1, destination IP is N8. But a router it is forwarding the packet from Alice to Bob. So the source remains the same. Alice wants the web page, and N8 is the web server. Achha. This particular network adapter will reframe, re-encapsulate using L4 as the source MAC address, L5 as the destination MAC address. A hopper destination key at the MAC level. At the MAC level, destination is this particular interface which has a MAC address of L5. Then it will encapsulate in this format, send it to the physical layer to physically transport it to, right? Physically forward it to this particular interface. This interface of R2 will receive it. It will see, okay, destination MAC address is L5, it is meant for me. I will receive the packet. It will do a parity check. Assuming parity check matches, it will send it to the network layer of R2. R2 will see, oh, it is packet arrived from N1. So it came from R1, but it from N1. And once again, I'm allowed to provide service to N1. I'm supposed to forward it to N8. It will look at its routing table. It will see that N8 in my router is on my left outgoing port, right? I have 3 ports, right one, left one, bottom one. So N8 happens to be this outgoing port. So I will forward the packet on this outgoing port. He will reframe. The internal part remains the same. IP addresses, sources N1, destination is N8. He will reframe as MAC address, sources L7, destination L8. Right? Put it on the physical layer, will forward it on this link. It will get to Bob's MAC LAN card. Network adapter will see, okay, MAC address is destination MAC address is L8. Money, it's meant for me. He will again decapsulate, give it to its network layer. Network layer, oh, IP address, destination IP is N8. That means the packet is meant for me. He will send it to the transport layer. Because IP address also feels, okay, it is meant for me. Send it to the transport layer. Please go over the full picture in your head. এখান থেকে আবার web page reverse হবে. ওই web page যখন আবার, well, the transport layer gives it the web page, right? Network layer will re-encapsulate as source IP reverse direction. Source IP তখন হবে N8, destination হবে N1. এই IP packet. Our MAC-টাও reverse করে will send it back on this line. It will get to this router R2. Router R2 will then see that the destination IP is N1, which happens to be on this port. He will re-encapsulate with the correct MAC addresses. তখন source MAC হবে এটা, destination MAC হবে এটা. Will go in this direction. R1 will again see, okay, destination IP is N1, which is in this link. Please go over it in your head. The whole thing, it is very systematic and logical. Very intuitive. Please. প্রত্যেকটা data part data থাকছে. And as far as the link layer is concerned, it's a very important point. As far as the link layer is concerned, ওর জন্য data part includes the IP addresses. For the link layer, data part includes the white part, white and the brown, or যে কালারটা ভেতরে হচ্ছে, বুঝতে পারছো? For the network layer, data part হচ্ছে যেখানে data বলা. For the transport layer, এর মধ্যে data হচ্ছে আরো subdivision আছে. Because actually data হচ্ছে from the application layer, right? It keeps on getting encapsulated and headers being added at every layer as it goes down. So to every layer, anything that came from the above layer is data. Is that clear to everyone? খুব ভালো কোয়েশ্চেন করেছে। এখানে হচ্ছে কি বুঝছো, মানে the slides are, I cannot make the slides, right? Myself, it will take a মানে কি বলে extreme amount of time, right? So the slides are from the publisher of the book. And sometimes they make not mistakes, but not the most teaching logical, straightforward representation. So I have to physically point that out. I have to verbally point that out myself. Instead of, if I was making the slides, instead of data, I will use the term layer 4 packet, right? Which is the block here. Okay. So next, Ashi. So link layer, again, link layer protocols have 3 different types. You have seen the types for unicast, multicast, and broadcast, what they mean. এখানে just বলা, so link layer addresses we know are 48 bits, right? And typically written in hex form, everyone. And this particular representation is reserved to mean broadcast, all ones. So if you look at your MAC address, you will not see any of them having this value. Usually অন্য কিছু example থাকবে, right? So this particular one is reserved for broadcast. I guess to mention করে দেই না। This is our 48 bits. This is our 48 bits. Sorry. Presented in 12 hexadecimal digits. Colons. Address, particular address, all 48 bits are ones. All 48 bits are all ones. For broadcast. Okay. A bit better. Okay, this is it. Finished stage up to section 9.2.1, a subsection. So এখানে যে homework quiz, this just means মানে under normal scenario, if you were taking physical classes, I would quiz on chapter 2 tomorrow in the next class, and in the online setting this means chapter 1 and 2, not 9, right? We just started. Previous chapters should be clear to you. You must be able to solve the homework problems by yourself at this point. Right? Once again, এই যে homework problem গুলো হচ্ছে as sample problems for the midterm, right? As mock problems. So you should be able to do those problems by yourself. Open book, right? With the book, with the resources around you, you should be able to do them by yourself in a small amount of time. এটাই মানে এখন on an exam, even though it is open book, you will not have time to search at that point. তখন the book is, I guess, if in case you have forgotten something, to quickly refer it. Obviously, I will not ask you definite, straightforward definition questions. Which in a take-home exam, it doesn't make sense. That's it. Today is Monday. So, chapter 9 a week, I will finish chapter 9. Next week, Monday is off for Eid. Wednesday, we have class, right?
Yes, sir.
Right?
Yes.
And by next Wednesday, I will try to finish the midterm. Whatever we finish, that will be the midterm syllabus. And a week after, I'm planning to take the midterm on the 16th. Okay. I think the 14th on a Friday.
Sir,
the
do we
plan
have
is
a
this week.
quiz?
We will finish chapter 9 this week. And next week, we have one class. So whatever we do up till that will be the midterm syllabus. Midterm will be a week after. Yes, go ahead.
Sir, do we have a quiz?
Say it again.
Sir, do we have a quiz?
No, because here, I mean, it's very difficult to take exams, right?
Yes,
So,
sir. Totally.
I
got it.
mentioned, I mean, I don't like this process myself, but unfortunately, we're going the national university method. Private, public university method. Whole grade will be on midterm and final. At least with the lab, 20% is on the lab. For the next rest, 80%, I have to do 30% midterm, 50% final. And midterm also, what I've decided is I will take a viva for each of you as part of the midterm. Essentially, what I'm planning to do is I will give you a bunch of questions on in a 1 hour time. We will at that time we will have the video on. Right, we will do however many you can in that 1 hour, and then I will check your scripts in front of you, all of you. That will be the viva. So we'll set up like a 10 or 15 minute slot for each of you, maximum 20 minutes, and I will check the scripts in front of you, and I will ask you as I check the script to tell me how you did each problem.
Sir, আমাদের কি হাতে লিখবো or just আমরা টাইপ করে পিসিতে
না,
অ্যানসার
টাইপ
করব?
করতে জাস্ট বেশি সময় লাগবে, হাতে লিখে ছবি তুলে পাঠাবা।
Okay, sir.
Right, I think that will make more sense.
মানে ছবি তুলে জাস্ট স্যার আপলোড করে দিব, তাই না স্যার?
আবার বলো।
ছবি উঠে আপলোড করে দিব।
হ্যাঁ, ওইটাই ওই ছবি তুলে এটা তো পারবা না?
জি স্যার, পারবো।
হ্যাঁ, sir.
That will be the fastest, right? মানে এখন এটা যেটা বলছিলাম যে মানে we are all learning, মানে I'm trying to do the best scenario of a fair exam and fair evaluation, right? Best possible scenario of a fair evaluation. This viva was Madhisar's idea. He did that last semester. Last semester at the end, 1 week, which many people requested grade increases, grade changes. So he gave them all an exam, and he essentially says, it takes me 10 minutes to check every script anyway. So I can do that simultaneously in front of you. Yeah, so I can make sure that you have done it yourself to some extent. Yes, and that will be part of the exam. Viva and written subdivide কিভাবে করব is a separate issue. পরে চিন্তা করব। ঠিক আছে? মানে once again please এই যে if you have suggestions you can tell me, তাই না? তুমি বললা লিখে দিবা, লিখে আমি টাইপ করতে বললে তো মানে you would have spent a heck of a lot of time typing, right? হাতে লিখে faster হবে না?
হ্যাঁ স্যার, faster.
মানে হাতে লিখে হাতে ছবি এঁকে ওইটাই স্ক্যানের চেয়ে ওই ছবি তুলে পাঠিয়ে দিলে। Okay, guys, the other thing to make sure your videos work. Okay, so the exam time, this is a university requirement that we have to have the video on. CITS requirement.
এক্সাম কবে বলেন স্যার? 14 আগস্ট।
Exam tentative plan is, that is what I'm thinking, 14th August Friday. 2 সেকশন একসাথে। ওই যে আমি 5 তারিখে সিলেবাস শেষ করব, ঠিক আছে? তারপরে 10th we may have a class which will not be part of the syllabus. 12th we won't have a class. I'll give you time off. 14th. ওই exam midterm week is 15th to 19th, ওই উইকটাই।
স্যার, কোয়েশ্চেন কি অনেক বেশি ডিফিকাল্ট হবে?
জানি না, যেটাই হয় যে বলো, আমি তো স্কেলিং করব, তো হাইয়েস্টটা ফুল মার্কস হবে, সো কিছু আসে যায় না তো, তাই না? অ্যাসাইনমেন্ট প্রবলেম যদি নিজে করতে পারো, ইউ শুড বি এবল টু আনসার অল অফ দেম, বুঝছো? রাইট, অ্যাসাইনমেন্টের যে প্রবলেমগুলো আছে এগুলো যদি বই না দেখে করতে পারো, বই বলছি ওপেন, বাট বই না দেখে আমি বলছি ইন দ্য ইন্টারেস্ট অফ টাইম, রাইট, ওগুলো যদি করতে পারো ওইটার থেকে একটু চেঞ্জ করব, বাট কিছু না, মানে একটু চেঞ্জ বলতে কি, আমি টোপোলজিটা চেঞ্জ করতে পারি, ভ্যালু চেঞ্জ করতে পারি, এর থেকে বেশি তো করতে পারি না, তাই না? মানে মানে মাই অবজেক্ট ইজ নট টু, কি বলো, মানে আবার ওই যে ফেয়ার এক্সাম মানে কি, ইট মাস্ট কভার দি অ্যাপ্রোপ্রিয়েট সিলেবাস। So I will not give you a 400 level question. I will give you a question relevant to this class. Right?
Sir, do we have lab midterms as well?
ল্যাবের লাস্টে একটা ভাইভা নিব এন্ড জাস্ট ল্যাব রিপোর্টস ওই পর্যন্ত। লাস্টে আবার কি করতে পারে কি, অ্যাজ আ পেয়ার ওই যে he'll make you মানে do a simple network by yourself, right, solve some network
Okay.
problem, ওই যে যেগুলো করছো, do some simulation in real time.
Okay, sir.
My idea is you can do it as a pair. If মানে among the two of you one person does it, you can both get marks. মানে অত সাব ডিভাইড করার দরকার নাই এসি জায়গাতে, ঠিক আছে? মানে because you cannot even physically meet, right? আচ্ছা, ওইটা লাস্টে, সেটাও আমি আনফেয়ারলি যাই না, ঠিক আছে? মানে আই ট্রাই টু বি ফেয়ার। সো ফাইনালও ইউজুয়ালি আই ফিনিশ দ্য সিলেবাস a week before the final. মানে বিকজ এই যে ইন দ্য সেমেস্টার সেটিং, মানে পাবলিক ইউনিভার্সিটিজ ইউ হ্যাভ আ মান্থ টু স্টাডি বিফোর এক্সামস। এখানে মিড টার্ম আই ট্রাই টু গিভ ইউ অ্যাট লিস্ট ওয়ান ক্লাস অফ, সো দ্যাট ইউ হ্যাভ অ্যাট লিস্ট হাফ আ উইক অফ, অ্যান্ড ফাইনাল আই ট্রাই টু গিভ ইউ আ ফুল উইক অফ। ঠিক আছে, দেখি চ্যাপ্টার 9 থাকবে, চ্যাপ্টার 9 তো শেষ হবে এই উইকে শেষ হবে, সো উই উইল হ্যাভ ওয়ান মোর ক্লাস, রাইট? Chapter 5 as the mid syllabus, one on August 5th, and then August 10th I will take a class which will not be in the syllabus, in the mid syllabus. So সেটাই বলছি যে on August 12th I won't take a class, right? So মানে sounds fair and reasonable. অন্য সেকশনের I'm making them do a makeup class on the 4th, even though university is closed. ওই একই ইয়াতে যে তাইলে I'll reduce a class at the end near the midterm, তাই না? মানে এখন 1 week off at this point seems unnecessary. I would rather have the time off before the midterm, right? মানে since we're all home, right? ঈদে বাড়ি যাবা, বাড়িতে আছোই, আর বাড়ি থেকে বেরোতে তো পারবা না, তো ঠিক আছে। Okay everyone, and আবার বলছি যে if you have any suggestions on improvements on মানে এই যে on teaching methods, on evaluation methods, please suggest, right? Because যেটা বলছি যে এটা আমিও কখনো করিনি এই মেথডে ক্লাস, তোমরাও যখন ক্লাস করোনি আমিও টিচ করিনি এই মেথডে কখনো। So I am trying to be, ওটা বলছি, fair, and to me এই যে fair means someone who deserves a B should get a B, should not get an A, should not get a C, তাই না? If everyone gets an A, then ওই GPA 5 এর মতো the meaning of an A is lost, right? And obviously you should not get a grade lower than what you deserve. Okay guys, so see you in the lab in 20 minutes if you have nothing.
Okay sir, thank you. Assalamu alaikum.
And আচ্ছা, খালি ওটা মনে রাখো যে ওই যে make sure all your video works for the midterm.
Okay, sir.
Okay.
Thank you, sir.
Okay.
Okay,
bye.
thank you, sir.
Yeah, see you in 20 minutes. Bye.